Good morning, all of you. So today, mechanical properties of fluids, session 11. In that, we will discuss about applications of Bernoulli's principle. So yesterday, we have discussed about Bernoulli's principle or Bernoulli's theorem. So we'll discuss about Bernoulli's theorem and the proof of the Bernoulli's theorem we understood. So we'll recall once. The Bernoulli's theorem states that the algebraic sum of for a fluid which is in motion, which is ideal, that means incompressible, non-viscous, rotational, then for a fluid which is ideal, incompressible, non-viscous, streamlined, steady, that means steady fluid, then the algebraic sum of that means the sum of the pressure energy, kinetic energy and potential energy per unit volume of the fluid is constant. Okay. Repeat once again. The Bernoulli's principle states that a fluid, ideal fluid which is in motion, the sum of the pressure energy, kinetic energy and potential energy per unit volume of the fluid is equal to constant. This is about Bernoulli's principle. And it is based on the law of conservation of energy. It is based on the law of conservation of energy. Now we are going to discuss about applications of Bernoulli's theorem or Bernoulli's principle. One by one we will discuss. Okay. So first we will say simple, after that we will go for complicated. Blowing off roofs by windstorms. Blowing off roofs by windstorm. By wind storms. So in olden days, have you observed in India, the houses are like huts, which is made of with leaves. On the top will make like this. Have you observed anytime? Nowadays also still poor people having a small huts. Yes or no? Nowadays slowly changing into concrete world, but in olden days it will be like that. So in such a case, you can observe the house or hut is like this normally. When you have a house or hut like this. Yes or no? Okay. So this is a small house. You can observe. Now the air is blowing. So let us say from left to right like this with a high speed. Okay, let us say speed of the air is very high. This is the air. Air is behave like a fluid. Okay. So fluid means it is a liquid or air. So that air is going with high speed. High speed means what happen? Then the pressure will be, you can observe, let us say pressure at this point P. And inside the pressure, let us say P naught. P naught means atmospheric pressure. P naught means atmospheric pressure. P is the pressure. Okay, pressure is changing because of the air is blowing from left to right. So because of the air is blowing, what happened? The speed of the fluid here very much high, V. When the speed is increases in a horizontal fluid, then what happened at that point the pressure, I observed yesterday, the last point of the speed of the fluid increases, at that point the pressure will be decreases. Pressure decreases at that point. I remember yesterday's last point. Yes or no? The pressure decreases. Yes, the pressure decreases, and the pressure how much decreases? Decreases below the atmospheric pressure. Below the atmospheric pressure. Then inside the house or inside the hut, you can observe there is a atmospheric pressure. Then this atmospheric pressure will be greater than the pressure on top of the roof. Okay. so that there is a pressure difference will be created because of P naught is greater than P. Okay, because of the air is flowing with high speed, the pressure decreases lower than the atmospheric pressure. So inside the house, so there is atmospheric pressure will be maintained. So that P naught is greater than P. Then inside air will make a upward lift like this. There is upward force will act by the inside air medium. This upward force will make there is a upward lift of the roof. So because of that, this roof will be lifted. This roof will be lifted up because of the high pressure created at the inside the house compared to low pressure in the topmost point of the roof. That will make the lifting of the roof upwards. Okay, so because of that, the roof starts lifting up. That will make a blowing of this roof because left side already air is coming now with high speed. So this will make this roof going away. This roof will be going away. Okay, this is the reason why the roofs are going away at the time of wind is blowing. Okay, here inherently the Bernoulli's principle is acting. The inside pressure is greater than the high speed air is going, so that pressure decreases. So that inside pressure will make the roof lifting upwards. Okay, so this is about the blowing of the roofs by wind storms. Are you clear this one? First application. Next we'll go for second application. Second application is that attraction between the parallel and closely moving boats. Attraction between the parallel and closely moving boats. Attraction between parallel and closely moving boats or ships. Okay. So in the water medium, suppose you can take two boats. Two boats are moving parallelly and closely inside the water. That means on the surface of the water. The roughly I have taken two boats here. So two are moving, let us say like this. So there is a small separation of water here. They are moving on waters. So what happened? Then you can observe here, whenever two boats are moving closely, two boats or two launches, whatever you can take. So the small separation if it is happen, let us say in between 10 meters, between 10 meters to 1 meter. Then in such a case, the liquid flow in between the boats, it will very fastly. That means water will flow in between the boats very fastly. That means relatively with respect to the boats. Okay. So when the liquid is flowing, that means water is flowing very fastly between the boats. Then what happened? Whenever liquid is moving very fastly, high speed, then there is a pressure P will be decreases between the boats. Pressure decreases between the boats immediately. Dynamically it will decrease. Pressure decreases. When the pressure decreases between the boats, then what happened? Say outside pressure you can see here, this side. There are three sides here. Side 1, side 2 is the in between the boats, and side 3. Then now you can observe, side 1 and side 3 is the normal pressure of the water. Let us say P naught. Whereas in between the two boats, P pressure, that P decreases. That P will become less than P naught. Okay. Then what happened? The pressure side 1 and side 3 will be normal pressure P naught, whereas the pressure in between the two boats, because of the water is moving fastly between the boats. Okay, so that pressure decreases. That pressure will be less than the P naught value. Then what happened? This pressure will make okay, this pressure will make Okay, pushing the boats, pushing the boats, pushing the boats towards each other. Are you clear this point? Pushing the boats towards each other. Pushing the boats towards each other. Are you clear this point? Then this will make accident of the boats also. This is the interesting thing. That's why any two boats or any two what you can say, any two traveling things that should not come towards each other. Yes, Manishwar, I'll explain in a second. When the two boats are moving parallelly with a small difference between them, that means a small distance, let us say 10 meters to 1 meter, then the waters in between the two boats will start moving fastly because of the relative momentum. Okay. Then whenever the fluid is, that means here water, fluid means water is moving very fastly, then the pressure will be decreases because of what? Bernoulli's principle again. Wherever liquid is or fluid is moving fastly, their pressure will be decreases automatically. Then outside of these boats, you can observe outside 1 and 3 sides, 2 is the between. Then 1 and 3 side, pressure will be normal, P naught, let us say. Then in between the two boats, the pressure decreases, P value less than P naught. Then this makes that outside water will push the boats from high pressure to low pressure, from P naught pressure to P, low pressure. Then this pushing of the boats towards each other, then there is a accidents will be created, okay, between the boats. Are you clear, Manishwar, now? So that's why we need to keep the boats or launches, whatever, we need to keep away. Okay, we need to keep away. That is about the second application. Next important application is Magnus effect. Magnus effect. Magnus effect. This application is very, very interesting, and for you people, youth, very, very interesting, because this is related to spinning of the ball. Spinning of the ball. Spinning of ball. That is so many applications in nowadays sports. What are those? You can take cricket, you can take football game, you can take football game, you can take tennis. In all the games, this spinning effect is playing a major role nowadays. Okay, so that is a Magnus effect. Okay, now we can see Magnus effect. So, what is Magnus effect? Yes, free kicking of the footballs mainly it will be used. Yes. Okay. So, in all the games, what we can see here, when a spinning ball is thrown, when a spinning ball is thrown, suppose when a ball is thrown normally, when a ball is thrown normally and when a spinning ball is thrown, what is the difference? There is a big difference. When a normal ball is thrown horizontally, then it will go horizontally without any effect. Whereas in the spinning ball, whether clockwise direction or anti-clockwise direction, when a spinning ball is thrown into the air, okay, then normally when a spinning ball thrown into the air, it deviates its path, okay, while it is moving. That's the main understanding. When a spinning ball is thrown horizontally into the air, then it deviates its path, okay, during its flight. During its flight, it deviates its path during its flight. This effect is called Magnus effect. What is the Magnus effect? When a spinning ball thrown horizontally in air medium, it deviates its path during its flight. During its flight. Flight means in motion in air. It during its flight, then it is called Magnus effect. Okay, but you can say it deviates its path. Deviates its path during its flight. During its flight. Okay, it is called Magnus effect. I clear this point? How it is deviates its path, I will tell you very clearly. It is called Magnus effect. Okay. Now you'll see the difference of two balls. First ball you can see without any spinning. This is the ball moving with a speed v. So outside this ball, what you can say have air medium. Air medium means it is a fluid. Air fluid is there. Then the aerodynamic lines will be like this. The fluid lines will be like this, upside and downside, when the ball is in motion. Okay. Normally, one more interesting point is that whenever it is deviating its path during its flight, that is called aerodynamic lifting also. Suppose if it is going upwards, then that is aerodynamic lift that we can see later. So here, normally without spinning, I draw this diagram. With a speed v, the ball is moving horizontally in air medium. Then the air molecules will propagate like this with respect to the ball. This is the ball. Are you clear this? Then there is no big effect here. Okay, slightly it will be shifted. Then in between ball will move. There is some air drag we can expect slightly. The next case, you can draw. This is the next diagram. This is the ball. You can see this is the ball. Again, it is moving with the speed v. Horizontally, it is moving. Okay. And now it is spinning also. Suppose if it is spinning clockwise, CW, clockwise with angular velocity omega. Okay. Then this is spinning. Right. Now v is the speed with respect to the air medium. We can say this is the horizontal speed. Now air is the air molecules are like this again. Deviate its path slightly. Okay. Now, while it is spinning, there is additional speed will come now. What is that? Suppose let us say r is the radius of the ball, then r omega. Then what is the speed? Additional speed v dash is equal to v already center of mass speed plus r omega. In rolling motion, we have discussed now. I remember when the ball is rolling, that is spinning or rolling are same. So here v, that means actually here rolling only the ball both spinning and moving horizontally, both spinning and moving horizontally. Okay, so that means you can say simply in air medium it is spinning and moving horizontally, so that rolling case only. So the total speed at the topmost point you can say v plus r omega. You can see here clockwise direction. The rotational effect will make r omega speed because angular speed is omega na. Then because of the angular speed, we have a linear speed at the topmost point of the roller or a sphere is v is equal to r omega. Now v dash is equal to, I said this is let us say v1 is equal to r omega, then v dash is equal to v plus v1. Okay, v plus v1 means v is the center of mass of the ball speed and r omega is the because of the rotation. So the total speed will become v plus r omega at the topmost point of the ball. And the bottommost point of the ball, see here, ball is moving horizontally from left to right, but rotational speed r omega it will make towards left because clockwise now r omega towards left. Then bottom side is the speed will become v double dash is equal to v minus r omega. Topmost point is v plus r omega, bottommost point is v minus r omega. Are you clear this point first of all? Yes or no? Tell me. In rolling motion we discussed. Okay, right. So while the ball is rolling in air medium, that is the during flight, it is a spinning with a horizontal speed v. So that total speed at the topmost point of the ball is v plus r omega, bottommost point is v minus r omega. Okay, so this is the first important point. Then because of this v plus r omega speed of the ball, Then air medium, this air also, air medium along with this ball near the surface of the ball, the air medium also will move with the speed of v plus r omega. The air medium, that means fluid. Fluid also will move with the speed of v plus r omega. At the bottommost point, air medium will move with the speed of v minus r omega. The fluid also will move with the v plus r omega at the topmost point, v minus r omega with the bottommost point. Then what is the difference we understood? There is a speed of the fluid, that means air. Then here air speed in upward direction is more. That means topmost point is more. Topmost point is, that means v dash, topmost point is greater than v double dash. That means at the bottommost point. From this, there is a speed difference from the topmost point to bottommost point dynamically. Okay. So then what you can say, when the speed is very high, then immediately what you can expect? There is a pressure. Pressure will be reduced. At the high speed fluid, pressure will be reduced. Let us say pressure P dash at the topmost point, P double dash at the bottommost point. Then P dash is less than P double dash. P dash is less than P double dash. That means pressure at the topmost point less than bottommost point of the ball, bottom of ball. Are you clear this? Spinning ball. So whenever pressure is less than, then what happens? There is a lift. Okay, dynamic lift upwards. That means the pressure, high pressure at the bottommost point will make the ball lifting upwards. Okay, then the ball slightly lifted upwards because of the pressure difference. Okay, this lifting is called aerodynamic lift. This lifting is called aerodynamic lift. Now what happened with respect to motion of the ball? Suppose on the ball, what you can expect? There is a force, gravitational force. Yes or no? The ball, what force you can expect? Gravitational force. Now, other than gravitational force, we have aerodynamic lift. Okay, because of the pressure difference. So that suppose because of the gravity, the ball has to drop here. At this point, it has to drop. Okay, because of the gravity. But now, because of the aerodynamic lift, it is lifted upwards slightly. Then the motion of the ball is shifted. The path of the ball shifted here. So this is the deviation of the ball. Deviation in its path. So instead of falling down at this location, it will be shifted slightly upwards so that its path will be deviated before landing at certain point. Are you clear this? The path of the ball is deviated because of the aerodynamic lift. Actually, because of it has to fall down. So instead of it is falling down immediately, it will be deviated its path because of the aerodynamic lift, so that it is landed somewhere. That means unexpected point, it will be landed. Are you clear this point? Yes. So normally this we can see in the leg spin and off spin, spinning of the balls. Okay, in the cricket. Similarly, in football also you can see in the free kick time. So the spinning of the ball will make the landing of the ball at the different location. What the normally keeper will expect, that point will not be falling lands. So that will make the goal. That will make the goal of the goal post. Okay. So these are the important application that we can do in games by spinning the ball. That is called Magnus effect. That is called Magnus effect. So for Magnus effect, you can apply this pressure difference simply by using Bernoulli's theorem. How to apply? I will show you. So let us say pressure at the bottommost point, topmost point, what I said P dash. Then what you can write? Equation of Bernoulli's theorem P dash plus half rho. Let us say rho is the density of air. Rho into V plus R omega whole square. V dash plus half rho V plus R omega whole square is equal to V double dash plus half rho V minus R omega whole square. Are you clear this equation? Here actually gravitational energy I neglected. Okay, because of gravitational energy will be same for the topmost point and the bottommost point. There is no big difference. Okay, only that the pressure difference P dash plus half rho V plus R omega whole square is equal to P double dash plus half rho V minus R omega whole square. Are you clear this equation? So here suppose here velocity increases na V plus R omega at this point, then pressure will be decreases at this point. Here velocity decreases V minus R omega, then the pressure at the bottommost point increases. Then this we can understand by using simply the Bernoulli's equation or Bernoulli's theorem. Are you clear this? Magnus effect application. Okay. So in this whatever lift it is coming, that same type of lift you can use in airplanes also, that aerodynamic lift. Because of the pressure difference, there is a dynamically upward motion will be created, upward lift. That lift we can call it as the aerodynamic lift. So that we can see now in airplane wing. In aeroplane, how the aerodynamic lift will be there, that we can see very clearly. Okay. So that lift we can say the lift or upthrust experienced by object, the lift or upthrust experienced by an object during its motion. The lift or upthrust experienced by an object during its motion of the object is called aerodynamic lift. Is called aerodynamic lift. This is very important. Aerodynamic lift. Okay, because of the pressure difference. Okay. Now I can say next application, that is aerodynamic lift on a airfoil. Dynamic lift on airfoil. What is this airfoil? I will tell you. Airfoil means the wing of the aircraft. The wing of the aircraft is called airfoil. Suppose you can draw a wing of an aeroplane. So roughly you can draw like this, the wing of the aeroplane. Like this. The wing of the aeroplane. Slightly I draw like this. So that topmost point is like a slightly convex shape and the bottommost point is like a slightly concave shape you can expect. This is like this. The wing of the aeroplane. Okay, it is like a wing of the bird. Now here, with respect to this wing, you can draw the air movement. This is the air movement. It will change the direction like this. This is the direction of air while it is moving. Aeroplane is moving. You can see this diagram. This is the direction of movement of the air with respect to wing of the airfoil. So this is the wing. Okay, right. Now, what is the speed? Speed of the air while moving. The wing is moving. Normally, wing will move. So in that case, you can say, let us say V1 will be the speed of the air upward direction, upside of the wing, and downside, let us say V2 is the speed of the wing. Okay. Then the pressure at the topmost point is P1, at the bottommost point is P2. Okay. You can observe here, the path traveled by the topmost point of the wing is more compared to bottommost point. The path traveled by the air. Then what happens? The speed obviously increases. Here speed V1 will be greater than V2. Same type of mechanism, only slightly different mechanism. So here V1 definitely, because of the, it is a convex in shape, the wing. so that it has to travel most amount of path, largest path, so that V1 should be greater than V2. Then when V1 will be greater than V2, then the pressure P1, what happened? Pressure P1 will be less than P2 according to Bernoulli's principle. The pressure P1 is less than P2. Then what happened? The pressure will be less than at the topmost point compared to the bottommost point. Then there is a pressure difference will create a dynamic lift upwards. Again, dynamic lift upwards while the aeroplane is in motion on the aircraft. So the dynamic lift will makes the aeroplane will be lifted upwards. Aeroplane will be lifted upwards. So this is called aerodynamic lift on the wings of the aircraft or the aeroplane. Okay. So here we can see the angle of attack also. Normally you can observe here there is a horizontal line you can draw. This is the horizontal level line. This is the level line with respect to the wing. And then you can draw with respect to chord of the this wing. Then another line you can draw. Another line. From this point you can draw another line like this. Okay. So it will make there is an angle between these two lines. Okay, this angle is called angle of attack of the air. This angle is called angle theta. This is called angle of attack of air on the aircraft wing. Angle of attack of air on aircraft wing. Okay, this theta value normally between maximum 3 degrees to 4 degrees. It should not be more than this. 3 degrees to 4 degrees. If it is greater than this, then it will make a resistance. Normally, this side what you can expect, air resistance. Air resistance. Okay, that opposes the speed also. So that angle it should be minimized. Okay, so yeah, this angle is called angle of attack of air on the aircraft wing. Okay, so here what is the dynamic lift? Once again, I'll explain on the airfoil. So here there is a wing will be made such a way that upside is convex shape, bottom side is concave shape, so that upside it will move with the air high speed because of the largest path it has to travel compared to bottom side. Then there is a speed difference of air will be created that will make the pressure will be reduced to the topmost point compared to the bottommost point. That will create there is a uplift. That means the pressure having high at the bottommost point of the wing will create an upward thrust, so that this upthrust will create a dynamic lift on the aircraft wing. Dynamic lift on the aircraft wing. Okay, that lift we can call it as the aerodynamic lift. Already I said it is a aerodynamic lift. That means already aircraft is in motion horizontally, and there is a pressure difference will be created from the bottommost of the aircraft to topmost point. That will create the aerodynamic lift on the wing that will give the lifting of the airplane. That will give the lifting of airplane. Okay, this is very, very important and interesting application by using Bernoulli's principle. Okay, again how to write? Again the same. P1 plus half rho V1 square is equal to P2 plus half rho V2 square. Here gravitational potential energy will be neglected because there is no gravitational potential energy difference between the bottommost point to the topmost point of the wing. Very small difference. Okay. Yeah, if you go fastly also, you can also fly, no doubt. But you have to create an aerodynamic lift. Manishwar. Okay. So based on this, if the pressure P1 is here, the speed V1 is greater, then immediately pressure P1 will be reduced. Here speed V2 is less, then pressure will be P2 will be high. Then that will create a pressure difference. That will create a pressure difference. Then that pressure difference will give the upward force. That pressure difference will give the upward lifting force. Okay. So for that you have to write very simply P2 minus P1. Yeah, this P2 minus P1 pressure difference is equal to half rho into V1 square minus V2 square. The gravitational potential energy per unit volume of the air is almost same because of the topmost point of the wing to bottommost point of the wing. Okay. So this is about some important applications related to Bernoulli's principle. Some more applications is there. Tomorrow I'll continue that.